Hi, this is Millie Kay, and it's Sunday, July 30th, 2017. And the subject of today's video is the 3 hydroelectric power plants at the Oroville-Thermalito Complex. And I've talked about the power plants before in other videos, but not all of them together in regard to hydroelectric power generation. So let's get started. I'll use this map I've gathered information about each power plant, and I'll be reading the information that I've put together. So there's 3 hydroelectric power plants at the Oroville-Thermalito Complex, and there's the Hyatt, there's the one at the diversion dam, and then there's the Thermalito power plant. And this whole area is the Oroville-Thermalito Complex. And I just want to point out that right here is the PG&E's Table Mountain substation, and that's where the power is transmitted to. It's PG&E's Table Mountain substation. It's estimated that the 3 hydroelectric power plants at the Oroville-Thermalito Complex combined generate about half the total power produced by the State Water Project's 8 hydroelectric facilities. And then I'll start off with the Hyatt power plant. The Hyatt power plant is a 645 megawatt underground hydroelectric pumping and generating facility. It's located in rock in the left abutment near the axis of Oroville Dam. Construction was completed in 1967. It's named for Edward Hyatt, who was state engineer of the Division of Water Resources. That was the former name for the Department of Water Resources. 3 of the 6 generating units are conventional generators driven by vertical shaft Francis-type turbines. The other 3 are motor generators coupled to Francis-type reversible pump turbines, allowing off-peak pumped storage operations. Static head is 410 to 676 feet. Above-ground overhead transmission lines extend approximately 9 miles from the switchyard to PG&E's Table Mountain substation. So that's the Hyatt. And then the Thermalito Diversion Dam Power Plant is a 3.4 megawatt above-ground hydroelectric generating facility. It was constructed between 1985 and 1987. It has 1 generating unit. Normal static head is 63 to 77 feet. It has underground transmission lines going to the Hyatt substation and the Feather River Fish Hatchery. And the third one, the Ronald B. Roby Thermalito Pumping and Generating Plant. It's a 114 megawatt above and below ground hydroelectric pumping and generating facility. The plant is named after Ronald B. Roby, former DWR director. Operations began in 1968, but construction was not completed until 1969. It has 4 total generating units, 1 Kaplan type and 3 Francis type. 1 unit is a generator and 3 of them are pump generators. Normal static head is 85 to 102 feet. The switchyard is located between the headworks structure and the powerhouse, utilizing a portion of the top deck of the powerhouse substructure. The transmission line extends approximately 2.3 miles from the switchyard to PG&E's Table Mountain substation. So that's the 3 power plants in the complex. And now I will show you a very basic graphic of the how hydroelectric power is made. And this is from the U.S. Department of Energy. It's very simplified. In this type of setup, such as at Oroville Dam, you have a reservoir and a dam, and the water comes in through an intake structure, and then it goes through a penstock to a turbine, and the the water causes the turbine to spin, and that turns the shaft, and then energy is created, and it goes through the generator and then through the transformer that makes it like at a higher voltage, and then it goes out through the transmission lines. And a turbine, I'll show you a couple of different kinds of turbines in a minute. A turbine has a runner that spins, and then when water comes out through the turbines, when it comes out, this is the tail race, is what it's called, as the water is exiting the turbines, and then this is the tail water. And when I speak of the head of the water, it's the head, it refers to the difference in height between the reservoir and this tailwater, to put it simply. And if you notice, just one more thing, this scroll casing, we'll be looking at that in a minute, of how these generators look. And before I do that, I do want to say a little bit about what happens to the power once it's generated, and how it's used. So I'm just going to read starting here. The State Water Project uses its power primarily to run the pumps that move State Water Project water to farmlands and cities, where it can be applied to economically beneficial uses and to provide peak power to California utilities. State Water Project long-term power contracts act as exchange agreements with utility companies. These exchange agreements allow the State Water Project and a utility to integrate the use of their individual power resources in a mutually beneficial manner. In these agreements, the State Water Project provides on-peak energy to the utility in exchange for the return of a greater amount of mid-peak and off-peak energy. The State Water Project may also receive other compensation in the form of annual monetary payments and/or reduced transmission service rates for State Water Project facilities served by the utility. Except during surplus conditions in extremely wet years, all State Water Project power is used for peak power exchange agreements and to operate pumping facilities. In all years, the State Water Project must purchase additional power to meet pumping requirements. So now let's move on, and I'll show you a couple of types of turbines. And there's two types of turbines in the Oroville-Thermalito Complex. There are mostly Francis turbines, and there's a total of, 11 turbines, and most of them are Francis turbines. So this is an example of a small Francis turbine sitting on its side, but you can see the runner, and then the shaft and the generator. And this is the shell casing. It looks like a snail's shell. And inside there are wicket gates, is what these are called, that control the flow of the water. So this one, the wicket gates are almost closed, and then here's one where they're more open. And I'll show you one huge inlet scroll that this is at the Grand Coulee Dam, and you can see when they're seated in their position. This is just the without the shaft showing, so you can see how that works. And then the other kind of turbine, they have one of these at the Thermalito plant, and this is a Kaplan turbine, and they look kind of like airplane propellers, the nose of an airplane. And so those are the two types of turbines. There's more kinds of turbines, but that's what they use in the complex. Next, I want to show you just briefly pictures of the power plants. The diversion dam power plant sits on the left abutment of the diversion dam, and so this is the diversion pool. And then I'll show you up close. This is the little power plant that just has the one generating unit, no pump back unit. This is the the Ronald B. Roby Thermalito Pumping and Generating Plant. And this is a really good DWR photo because it shows, here's this is the end of the forebay. And then you can see the dam, the power plant, the power lines. This is the tail race. And this tail race channel leads all the way to the after bay. And let me make this one bigger. And right now there's no pump back operation possible because it's not operational because there was that fire in 2012. And it's not expected to be back up and running until next year. I believe until late next year. And then you can see here how the transmission lines, they're just right there between the dam and the power plant structure. Part of this is above ground and part underground. And then you can see how the power line, the transmission lines, they're just a couple of miles from the PG&E substation. And next, let's look at the Hyatt, and it's underground, and this is what it looks like inside. So I'll just scroll through this a little bit. I'm going to be showing you some more details of the turbines. So they have a total of 6 turbines, and 3 are also reverse pump, and I've been told that they remove 1 turbine per year for maintenance, but there's room for 6. And here's the generators. So let's see what we have next. Oh, I wanted to show you this. This is the Google satellite view of the visitor's lookout. And the visitor's lookout is right here. And this is what it looked like before the spillway incident happened. So if you were driving along on Royal Oaks Drive, you would come to this big parking lot. And then you can park there and look out over the whole area. And in this, they have a turbine on display. And I'll show you that in a minute. And then you can, if you keep going on Canyon Drive, then it comes around and you can go right over the dam. And that's what it used to be like before they closed it off. You could go there and people would walk there, and then this is what it looked like in February. They turned it into a staging area. And so you can see where these are those white bags full of boulders that they were taking with the helicopters to fill the eroded areas. And then they had all this, this is where they would fill the bags. So that changed it quite a bit. And what it looks like, or what it did look like, is this is what that visitor area is in that corner. They have an old Francis turbine runner on display, This is the runner that they took out in 2007, and they set up this visitors area. It's nice. There's picnic tables over here covered and benches to sit on. And there's a sign here like they have at most, lookout points. And I'll be reading this sign to you, some of it. And I want to thank James V. For his generous permission to let me use a few of his photos in this video. James is an excellent photographer, and I really encourage you to go see his Flickr site, and I'll leave a link in the description box. And he's been to a lot of places, and he has photos of things like the Hanford reactor, and just places that you may not get to visit. And he has thousands of photos, and they're all excellent. So extreme thanks to James for letting me use these photos. So now let's go read the sign. And to do that, I need to go to my other program so I can manipulate the picture. So when you read the sign, it says hydropower generation. What has a diameter of 19 feet and weighs 165,000 pounds? This Francis runner from Edward Hyatt Power Plant. And so, let me make this a little bigger. It tells how hydropower works, but I kind of showed you that with that little graphic that I showed you. These are photos of them bringing the runner to the visitors area. So it's all loaded up on the big truck and brought over the dam and then lowered with a crane. And that was in 2007, because here's a photo of the new one. They had gotten this new one, and this one's going in. And I don't know how they even get it down there, but they do. And then this shows them putting it in, and this shows the whole, the shaft and the runner being installed. So now if we go back, let me see. Then it describes the different types of turbines. It talks about the Kaplan, the Francis, and some other ones, the Pelton. But the two that I want to focus on is the Kaplan. They have one of those at the Thermalito plant, and then the others are Francis. I'm not sure what the one is at the diversion dam. I could not find out what kind of turbine it is. I kind of assume it's a Francis. And then it talks about the two basic types of turbine runners, reaction and impulse. And the Kaplan and the Francis have the reaction kind. So I'm going to read this. The potential energy in the water is converted into mechanical energy in the turbine by one of two fundamental and basically different mechanisms. The water pressure can apply a force on the face of the runner blades, which decreases as it proceeds through the turbine. Turbines that operate in this way are called reaction turbines, Kaplan and Francis. This reaction principle can be seen in a rotary lawn sprinkler, where the jet flow of water drives the rotors in the opposite direction. And then it talks about the impulse type. And I want to read about, here's a good drawing of a turbine. How electricity is generated. Modern hydro generators produce power by converting the shaft torque into electrical energy. A small DC generator, exciter, produces a DC current. The current is circulated through strong electromagnetics electromagnets known as rotor poles. As the powerful electromagnets are rotated, the magnetic field induces voltage in the stator coils. This voltage is transmitted out of the powerhouse across transmission lines and ultimately to your home. And then, so here is your the graphic, and then here's a picture. Let me make it bigger. So here's the rotor, and then the Edward Hyatt power plant turbine units use a 32-pole rotor. Each pole weighs 6,000 pounds, and the rotor spins at 200 RPMs. So that's a good view of that. And then I just want to show you the let me make this smaller. So you have the Francis type here, and you can see the whole thing, the scroll case or the scroll inlet. The draft tube is down here. Here's the runner, and then it shows you the wicket gates and the shaft, and then the housing up here and then the Kaplan. Very similar, except for this runner part is real different. So that's that, and now let's go back to the next one. And I wanted to show you this now that we've talked about that Kaplan turbine, because the Ronald Roby power plant, this is the Kaplan turbine that it's getting brand new, because the Kaplan that was in there was destroyed by the fire in 2012, and I'll show you a picture of the burned out one. So that was a mess. So that one gets replaced. I think this must be a propeller for it. I really don't know. I really couldn't say exactly. I'm thinking it's the propeller blade thing that goes, I call it a propeller, the blade that goes on there, but I really can't say that for sure. And then the other units got refurbished. So let me make this smaller. Unit 2 is getting refurbished. I don't know what piece this is, but Unit 2 is getting refurbished, and Units 3 and 4 are getting refurbished. And on there you can see they're bringing this Francis runner out. You can see the dam back here, and then this is the powerhouse they're bringing it out of. I assume they're bringing it out. It looks scorched. I don't think it's coming back. And then this shows some of the refurbishment as well. I'm thinking this must be those controls for the wicket gates, but there again, not totally sure about that. So I'm going to leave you with this photo of the Francis runner at the Visitors Lookout Point. And I really appreciate your viewing my videos, and I hope you will like, subscribe, and share. And I'll see you next time.